Discrete means number of whole numbers usually. Continuous means can be fractions or decimals as well as whole numbers. Speed of an airplane, that's continuous. Ages of college professors, continuous. Although I would maybe argue for discrete. You could maybe argue for discrete with me on that one. Number of books in the college bookstore. There's only going to be 3 books, 4 books, 83 books. That's discrete. Number of. Weight of a football player. That could be in the middle of a pound, like 200.3 pounds. So that's continuous. Number of lightning strikes. That's countable. That's number of. That's discrete. Is this a valid probability distribution? Why or why not? In a probability distribution, these are the probabilities of x happening 0 times, x happening 1 time, or x happening 2 times. We don't know what x is. But in a probability distribution, all the probabilities have to add up to be 1. And ours don't. They add up to be 1.05. You can't have 105% things happening. It has to be 100%. So this is not a probability distribution because the probabilities do not add to 1. Probability distribution. I like to write my probability distributions this way. The book does them this way. I'll show you why I like my way. First off, x. The x is what's going to happen. So we're going to have a $1 bill, a $5 bill, a $10 bill, and a $20 bill. The p of x is the probability that each thing will happen. So let's see. We've got 3 dollar bills, 2 $5 bills, 1 $10 bill, and 1 $20 bill. So how much is that all together? 1, 2, 3, 4, 5, 6, 7. There's 7 bills all together. So that means that if I've got 3 $1 bills, the probability is 3/7, 3 out of 7, that I'll get the 1. There's 2 $5 bills, so that's 2/7 that I'll get the 5. And 1 $10 and 1 $20. So the probability that I'll draw a 10 or a 20 is 1/7. The reason that I like this way better is a lot of times you might be asked to find the expected value. You're not here. This is the answer to this problem. But to find expected value, all you need to do is make an xpx column where you multiply the x times the px and then sum them. So sum this column, and then that would give you your expected value. Construct a probability distribution for a family of 3 children. Let x represent the number of boys. So I've made my probability distribution. I've listed out all the possible things that could happen. We've made this list a number of times, sometimes with heads and tails, sometimes with having 3 children, boys and girls. Okay, here's all the ways that you could have 3 boys. Here's all the ways that you could have 2 boys. Here's all the ways you could have 1 boy. Here's all the ways you could have 0 boys. So x is the number of boys you have. So if x is 0, 0 boys, how often does that happen? What's the probability? There's 8 choices here altogether, so my sample space size is 8. And 1 out of the 8 choices has 0 boys. So the probability of getting 0 boys is 1/8. How about of getting 1 boy? That's this list. So there's 3 in that list, so 3 out of 8 is the probability of getting 1 boy. How about of getting 2 boys? Also 3/8. Of getting 3 boys, 1/8. Notice in a probability distribution, if I add up 1/8, 3/8, 3/8, and 1/8, I'll get 8/8. Or 1. The probabilities in a probability distribution always sum to 1. If I wanted to find expected value, I'd make another column where I take x times px, and then I would sum those values, and this number right here would give me the expected value of number of boys in a family. X is the number of fish caught in a 6-hour period. So This x equals 0, means that the fisherman caught 0 fish in the 6-hour period. The probability of that happening is 0.44, or 44%. Here's 1 fish caught, there's the probability. 2 fish caught, there's the probability. Note that the probabilities have to add up to 1, 100% of what's going on. So find the probability that a fisherman selected at random fishing from shore catches at least 1 fish in a 6-hour period. At least 1 means that he could get 1 or 2 or 3 or 4 or more. So just add together all those probabilities. Another way to do that is we know that at least 1 means that he didn't get 0. So we could use the complement rule and say 1 minus the probability that he catches 0. Either way, 0.56. Find the probability that a fisherman selected at random fishing from shore catches no fish. So what's the probability he gets no fish? Right there, 0.44. How are the answers in problems 5 and 6 related? Just like we talked about in number 5, they're complements of each other. At least 1 fish is the complement of no fish. Or their probabilities add to 1. Find the probability that a fisherman selected at random fishing from shore catches 2 or more fish. 2 or more would be you could catch 2, or you could catch 3, or you could catch the 4 or more. That means greater than or equal to 4. So just add all those probabilities. 0.15 probability of getting 2, 0.04 probability of getting 3, 0.01 probability of getting 4 or more. 0.2, 20%. I'm going to fill out my table, x times px and x squared times px. I'll just use the 3 for an example. The x is 3, the px is 0.04. So x times px is 3 times 0.04. X squared times px, I take 3 and square it. 3 times 3 is 9. 9 times 0.04 is 0.36. I'll fill out the rest now. In order to find mu, the mean, and sigma, the standard deviation, I need to figure out the sum of the xpx column and the sum of the x squared px column. So I just add all these numbers. And this means add up all the numbers in this column. So I'll do that, add these numbers. Compute mu, compute sigma. The most important thing here is knowing where to find these formulas. You want to look on your formula sheet, chapter 5, and find mean for a probability distribution and variance and standard deviation for a probability distribution, and then copy those formulas. It tells me on my formula sheet that mu is the sum of x times px. And it tells me that sigma is the square root of the sum of x squared px minus mu squared. The first one's easy. The sum of the xpx column, I already found that, 0.82. So mu is 0.82. Standard deviation is a little trickier, but not too bad. I'm going to take this right here, the sum of x squared px. That's this. the sum of x squared px. Well, what about this? Where am I going to get this? Mu squared. Well, I know mu is 0.82, so I'm just going to sub that stuff in there. I'll have the square root of 1.48 minus 0.82 squared. The 1.48, that's the sum of the x squared px column. The mu comes from the mu that I just figured, 0.82 squared. You can type this all into your calculator at once, or I like to do what's this stuff first, 1.48 minus 0.82 squared. I type that into my calculator. And then I do the square root of that number. I'll round to 3 decimal places, and I get 0.899. There's the standard deviation. There's the mean.